Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Last week, we locked down the network perimeter with Azure Firewall and DDoS protection. This week, a security audit discovers something worse. 23,000 customer records have been sitting in a publicly reachable Azure storage blob container for 3 months. No network restrictions, weak access controls, and nobody noticed. Here's the important lesson. This isn't necessarily a sophisticated hack. Cloud data exposure often happens because multiple security controls were configured incorrectly or never configured at all. Properly configured network restrictions, combined with strong authentication and authorization controls, could have greatly reduced or prevented unauthorized internet access. Today, we're going to examine 2 important Azure networking technologies: service endpoints and private link. We'll look at what each one actually protects, what each one doesn't protect, and how to choose the right architecture for production workloads. By the end of this video, you'll have 3 practical Azure networking skills. First, you'll know how to enable a service endpoint on a subnet and restrict a supported PaaS resource, such as Azure Storage, to approved virtual networks. Second, you'll understand when to evaluate private link, especially when you need private IP-based connectivity from Azure, hybrid networks, or supported cross-tenant architectures. Third, you'll know the security controls that must work together for a strong private endpoint deployment: private connectivity, correct DNS, public network restrictions, and identity and authorization. No theory dump. We're going to focus on the patterns you'll actually use when designing and troubleshooting production Azure environments. Here's an important security reality. Many Azure PaaS services expose public endpoints by default or permit public network access until you explicitly restrict them. The exact default varies by Azure service and deployment configuration, so always verify the networking posture of the resource you're deploying. And remember, a public endpoint does not automatically mean the data itself is publicly accessible. Authentication, authorization, anonymous access settings, and service-specific controls still matter. But leaving unnecessary public network access available increases your attack surface. That's why one of your first security decisions should be, which networks actually need to reach this service? Azure gives us 2 important technologies for controlling that access: service endpoints and private link. Before we fix anything, let's understand the default path. Your VM or application connects to a service name such as storageaccount.blob.core.windows.net. Without additional network restrictions, that name resolves through Azure's normal public service endpoint architecture. Here's an important distinction. A public endpoint does not automatically mean your data is publicly accessible. Network reachability and data authorization are 2 different security layers. Azure Storage, for example, can still require Microsoft Entra authentication, RBC, SAS tokens, or other authorization mechanisms. But if the public network endpoint is available, clients outside your trusted network may still be able to reach that endpoint and attempt authentication. Our goal today is to reduce that network exposure. And Azure gives us two major approaches: service endpoints and private endpoints. Azure gives you two major ways to restrict how workloads reach supported PaaS services. The first is a service endpoint. A service endpoint extends the identity of your virtual network and subnet to a supported Azure service. Your workload still connects to the service's public endpoint, but the traffic uses the Azure backbone, and the PaaS resource can be configured to accept traffic only from authorized VNets and subnets. The second approach is private link, delivered to your VNet through a private endpoint. A private endpoint creates a network interface with a private IP address from your VNet address space. Your applications can then reach the supported PaaS service through that private IP path. But here's something we're going to repeat throughout this video. Creating a private endpoint does not automatically mean the service's public network access has been disabled. Private connectivity and public network access are separate controls. Understanding that distinction is the key to designing this correctly. Quick checkpoint. If an Azure storage account has a public service endpoint, does that automatically mean anyone on the internet can read its data? No. Network reachability and data authorization are separate security layers. A client might be able to reach the public endpoint, but still need valid authentication and authorization, such as Microsoft Entra ID with RBAC, a SAS token, or another supported authorization method to access the data. That's an important distinction. Networking determines whether you can reach the door. Authorization determines whether you can open it. Here's the comparison you'll want to remember. With a service endpoint, your workload still connects to the PaaS service's public endpoint. But traffic from the enabled subnet uses the Azure backbone, and the service can recognize the VNet and subnet identity. You then configure the PaaS firewall or network rules to allow that trusted subnet. With private link, the model changes. You create a private endpoint with a private IP address inside your VNet. Your application resolves the normal service name to that private path through the appropriate DNS configuration. This makes private link especially useful when you need private connectivity from Azure workloads, hybrid networks, or other supported connected networks. But remember, private endpoint does not automatically equal public endpoint removed. Where the service supports it, you should separately disable or restrict public network access when your security requirements demand private-only connectivity. That's one of the biggest differences we'll demonstrate today. Now let's look closely at the service endpoint data path. Imagine your VM has the private IP 10.0.1.5. You enable the appropriate service endpoint on that VM subnet. The workload still connects to the normal public service endpoint. For example, storageaccount.blob.core.windows.net. But traffic to the supported Azure service uses Microsoft's Azure backbone, and the service can identify the originating virtual network and subnet. You then configure the storage account's network rules to allow that subnet. That's the important combination. Enabling the service endpoint establishes the network capability. Restricting the PaaS resource to selected networks actually enforces which networks are allowed. If you enable the service endpoint but leave the storage account open to all networks, you haven't accomplished the network restriction you intended. Let's configure this in the Azure portal. First, open your virtual network. Select subnets. Choose the subnet containing your application. Under Service Endpoints, select the supported service you need. For this example, Microsoft.Storage and save the configuration. But don't stop there. The second step is just as important. Open your storage account and go to its networking configuration. Restrict network access according to your design and add the VNet and subnet you just configured. Now the storage network policy can allow traffic from that authorized subnet while denying network access that doesn't match your permitted configuration. And remember, this is network access control. The client still needs valid authorization to actually read or modify the data. Networking determines whether you can reach the door. Identity and authorization determine whether you can open it. Here's the pattern you'd follow to lock a subnet down from the CLI. The first command enables the service endpoint on a subnet, telling Azure to treat outbound storage traffic as coming from your VNet. Then you add a network rule that tells the storage account to only accept traffic from that specific subnet. The actual parameter values will depend on your environment, but this is the shape of the commands that secure the path in seconds. Here's the limitation you need to understand with service endpoints. The PaaS service still uses its public service endpoint. The security comes from restricting the PaaS resources' network access to approved virtual networks and subnets. That means configuration matters. If someone later changes the storage account network policy and allows broader public network access, clients outside your trusted subnet may once again be able to reach the service's public endpoint. That does not automatically mean they can access your data. They would still need whatever authentication and authorization the service requires. But you've increased the network attack surface. That's why service endpoint security depends on two pieces working together. Enable the service endpoint on the subnet and restrict the PaaS resources network rules. Don't configure one and forget the other. Quick checkpoint. Can a traditional service endpoint give an application in your on-premises data center a private IP destination for Azure SQL database? No. Service endpoints extend VNet and subnet identity to supported Azure services, but they don't create a private IP endpoint inside your VNet for an on-premises client to reach. If your requirement is private IP-based connectivity from on-premises through VPN or Express route, evaluate private link and private endpoints. And remember, routing alone isn't enough. Your DNS architecture must also resolve the service name to the correct private endpoint IP. Now imagine a company has a stricter requirement. Their Azure SQL environment shouldn't be reached through the normal public network path. Their security architecture requires applications to connect through private IP addressing from trusted Azure and hybrid networks. This is where private link becomes extremely valuable. Instead of relying on access to the service's public endpoint combined with VNet firewall rules, you create a private endpoint inside your VNet. That private endpoint receives a private IP address from your subnet. Your applications can then connect to the supported PaaS service through that private endpoint path. But don't make the common mistake of stopping there. If the requirement is private-only access, you also need to review the PaaS service's public network access configuration and disable or restrict public access where supported. Private endpoint gives you the private path. Public network settings determine whether the public path remains available. Now look at the private link architecture. Your VM might have the address 10.0.1.5. The private endpoint might receive 10.0.1.10. That 10.0.1.10 address comes from your VNet address space. Your application connects using the service's normal fully qualified domain name, but properly configured DNS causes that name to resolve to the private endpoint path. Traffic reaches the private endpoint and then uses Azure Private Link to reach the supported service. The important architectural difference is this. Your client now has a private IP destination inside your network, but don't interpret that as meaning the PaaS service itself has lost every public endpoint. Private endpoint creates a private connectivity path. If your requirement is private-only access, separately disable or restrict public network access on the PaaS service where that capability is supported. Private connectivity plus public access restriction is what creates the stronger isolation model. Let's create a private endpoint. In the Azure portal, start the private endpoint creation workflow. Choose the target PaaS resource. Then select the correct sub-resource. For Azure storage, that might be blob or file. For another service, you'll select the appropriate supported sub-resource. Next, place the private endpoint into the VNet and subnet from which it should be reachable. Azure assigns the endpoint a private IP address from that subnet. Then comes one of the most important parts of the deployment: DNS. Your clients need to resolve the service's normal FQDN to the private endpoint path. Azure private DNS zones are a common way to accomplish this, but they're not the only option. Larger hybrid environments may use custom DNS servers, Azure DNS Private Resolver, conditional forwarding, or other supported DNS designs. The requirement isn't, you must always use one particular DNS architecture. The requirement is, the client must resolve the service name to the correct private endpoint IP when private connectivity is intended. Here's the deployment pattern from the command line. First, create the private endpoint and connect it to the correct PaaS resource and sub-resource, such as blob for Azure storage. Next, configure the appropriate private DNS integration. If you're using Azure Private DNS, a private DNS zone group can associate the private endpoint with the appropriate private DNS zone and manage the endpoint's DNS records. But the zone group alone doesn't guarantee that every workload will resolve the service to the private IP. The private DNS zone must also be linked to, or otherwise resolvable from, the client networks that need to use the private endpoint. In hybrid environments, that might involve Azure DNS Private Resolver, conditional forwarding, or custom DNS infrastructure. After deployment, always validate from an actual client. Resolve the service's normal FQDN and confirm that the client ultimately receives the expected private endpoint IP. That's the test that matters. Here's one of the most important lessons in this video. Creating a private endpoint gives you a private connectivity path. It does not necessarily disable the PaaS service's public network access. Those are separate controls. So when your requirement is private-only access, think in layers. Layer 1. Create the private endpoint. Layer 2. Configure DNS so trusted clients resolve the service to the private endpoint. Layer 3. Disable or appropriately restrict public network access on the PaaS resource where supported. And Layer 4. Apply authentication and authorization controls such as Microsoft Entra ID, managed identities, RBAC, SAS policies, or whatever the service supports. Private networking determines how clients reach the service. Identity determines what authenticated users and applications are allowed to do. You need both. Quick checkpoint. You created a private endpoint for a storage account. Does that automatically mean the storage account can no longer be reached through its public network endpoint? No. A private endpoint creates a private connectivity path. For a private-only design, remember 4 layers. 1. Private endpoint. 2. Correct DNS resolution. 3. Public network access disabled or appropriately restricted where supported. 4. Strong authentication and authorization. If you remember those 4 layers, you'll avoid one of the biggest private link design mistakes. Private endpoint gives us the private connectivity path. Now let's look at additional network controls. Depending on the service, subnet configuration, and your security requirements, network security groups and user-defined routes can be part of your private endpoint architecture. But there's an important Azure configuration detail. Where you plan to apply NSGs or UDRs to private endpoint traffic, make sure the relevant private endpoint network policies are enabled on the subnet and supported for your design. Then start with the actual traffic requirement. Which application subnets need connectivity? Which ports and protocols are required? Do on-premises networks need access? Should traffic pass through a firewall or another inspection point? Design your NSGs and routing around those requirements instead of blindly adding deny rules. And remember, network controls don't replace service authorization. A workload being able to reach a private endpoint doesn't automatically give it permission to read a blob or query a database. Network connectivity and data authorization remain separate security layers. Quick checkpoint. A VM can successfully connect to the private IP address of your storage private endpoint. Does that mean the VM can automatically read every blob in the account? No. The private endpoint provides network connectivity. The application still needs valid authentication and authorization. For example, Azure Storage might use Microsoft Entra ID with RBAC, a Managed Identity (SAS), or another supported authorization method. Remember, reachability answers, "Can I get to the service?" Authorization answers, "What am I allowed to do once I get there?" Enterprise security requires both. Private link becomes especially powerful in hybrid environments. Imagine an application running in your on-premises data center needs to reach Azure SQL database privately. Your on-premises network connects to Azure through ExpressRoute or a site-to-site VPN. The client routes into Azure and reaches the private endpoint using its private IP address. From there, Azure Private Link provides connectivity to the supported PaaS service. But routing is only half of the design. DNS must work too. Your on-premises client needs to resolve the service's normal hostname to the private endpoint IP. That's why production hybrid private link architectures often include DNS forwarding, Azure DNS Private Resolver, custom DNS servers, or another supported hybrid DNS design. Service endpoints don't provide this same on-premises originated private endpoint model. That's one of the major reasons private link is so important for hybrid architectures. Money matters. There's no additional charge for enabling service endpoints on a subnet. Private link, on the other hand, introduces additional costs. Private endpoints can have hourly charges and data processing charges, depending on the service, region, and current Azure pricing model. Those costs can add up when you deploy many private endpoints or process large amounts of traffic. The additional cost may be justified when private IP-based connectivity and stronger network isolation are requirements. But don't assume private link is free just because the traffic stays on Azure's private networking infrastructure. Always check Microsoft's current Azure private link pricing before designing a production deployment. Service endpoints are generally the simpler architecture. You enable the appropriate service endpoint on the subnet. Then, you configure the PaaS resources network rules to trust that subnet. Private link introduces additional components. You create the private endpoint. Select the correct sub-resource. Plan IP addressing. Configure DNS. Validate name resolution. Review routing and network controls. And if the requirement is private-only access, disable or restrict the PaaS service's public network access where supported. Hybrid environments may also require DNS forwarding and additional routing design. That's the real trade-off. Service endpoints are operationally simpler. Private link gives you a private IP-based connectivity model, but introduces additional networking and DNS responsibilities. The right answer depends on the requirement, not the number of portal clicks. Here's a better way to choose. If you need straightforward VNet-based restrictions for a supported Azure service and the public service endpoint model is acceptable, consider service endpoints. If you need a private IP destination inside your VNet, consider private link. If on-premises systems need private connectivity to the PaaS service, private link is often the appropriate architecture. If strict security requirements call for disabling public network access, private link combined with the service's public access controls becomes especially important. If your concern is data exfiltration through service endpoints, investigate service endpoint policies for supported services and scenarios. And always evaluate service support, DNS, hybrid connectivity, cost, operational complexity, public network requirements, and identity and authorization. Don't choose based on which technology sounds more secure. Choose based on the traffic and security requirements you're actually trying to satisfy. Here's an architecture mistake that's easy to make. A company builds its application around service endpoints because all workloads initially live inside one Azure VNet. Then, the environment changes. The company adds on-premises applications. Another Azure network needs access. A merger introduces additional connectivity requirements. Or workloads need a private connectivity model that extends beyond the original subnet design. Now, the original service endpoint architecture may no longer satisfy the requirements. That doesn't mean service endpoints were wrong. It means the requirements changed. Private link can provide a more flexible private endpoint model for many hybrid and multi-network scenarios, but support and design details vary by Azure service. The lesson is, don't choose networking architecture only for today's application. Ask where the consumers of that service may live 2 years from now. Architecture checkpoint. Your application currently runs entirely inside Azure and a service endpoint satisfies the network requirement. 6 months later, an on-premises application also needs private connectivity to that same PaaS service. Which technology should you evaluate? Private link. Why? Because a private endpoint gives connected networks a private IP destination that can be reached through an appropriately designed VPN, ExpressRoute, peering, and DNS architecture. But remember, private link isn't selected simply because it's more secure. You select it because its connectivity model satisfies requirements that service endpoints may not. Now let's apply the 4-layer model we learned earlier to DNS. A client normally connects to an Azure service using its standard fully qualified domain name. When that client should use private link, DNS needs to direct it to the private endpoint path. If DNS is correct, the client resolves the service to the expected private endpoint IP. If DNS is wrong, the client may attempt the public path instead. What happens then depends on your public network configuration. If public access is permitted, the connection might use that path. If public access has been disabled, the connection should fail. So when private endpoint connectivity breaks, don't immediately blame routing. Check DNS. Let's verify it from the workload itself. Open a command prompt or PowerShell session and run nslookup against the service's normal fully qualified domain name. We want the DNS chain to ultimately return the expected private endpoint address. For example, 10.0.1.10. If you get the expected private address, DNS is pointing this client toward the private endpoint. If you get the public service path instead, investigate your DNS configuration. Check the private DNS zone if you're using one. Check VNet links. Check custom DNS forwarding. And in hybrid environments, verify your Azure DNS private resolver or conditional forwarding configuration. Remember the rule from earlier. The client must resolve the service to the correct private destination. After deployment, validate two things: the private endpoint itself and DNS. First, confirm that the private endpoint is connected to the expected resource and has the expected private IP address. Then, validate your DNS architecture. If your design relies on Azure private DNS zones, verify that the required zone, records, and VNet links exist. For Azure Blob Storage, for example, your architecture may use privatelink.blob.core.windows.net. If you're using custom DNS instead, validate the equivalent forwarding and resolution configuration. The final test should always come from a real client. Does the service's normal FQDN resolve to the expected private endpoint IP? That's what ultimately determines whether your DNS design is working. Service endpoint policies and network security groups solve different problems. With supported service endpoint scenarios, service endpoint policies can help restrict which specific Azure service resources traffic from a subnet is allowed to reach. That can be valuable for reducing data exfiltration risk. For example, you don't just want a workload subnet reaching any storage account. You may want it reaching only approved storage resources. NSGs solve a different problem. They control network flows based on attributes such as source, destination, port, and protocol. They can be part of a private endpoint security architecture where applicable, but they don't replace service-level authorization. Then you add another layer, identity. Even when the network path is allowed, Microsoft Entra ID, RBAC, managed identities, SAS policies, SQL permissions, and other service-specific controls determine what the caller can actually do. Network controls reduce reachability. Identity controls permissions. Data exfiltration defense often needs both. Final DNS checkpoint. Your application should use a private endpoint, but DNS points it toward the public service path. What happens? It depends on the public network configuration. If public network access is still permitted, the client may attempt that path. If public network access is disabled, the connection should be denied. That's why DNS and public network restrictions work together. DNS directs the client toward the intended path. The PaaS network configuration determines whether alternative paths are permitted. Now let's scale this beyond one storage account. Azure Policy can help enforce your organization's network security requirements across subscriptions and resource groups. For example, policies can audit or restrict resources that allow public network access. Other policies can audit whether private endpoints are configured according to your organization's standards where supported. But don't think of one policy setting as magically creating a private link-only architecture. At scale, you typically combine governance controls, public network access requirements, private endpoint requirements, DNS standards, resource configuration, and identity controls. Azure policy helps prevent configuration drift and identifies resources that don't match those standards. That's how enterprise security scales, not by hoping every administrator remembers the checklist, by turning the checklist into policy. Even after service endpoints or private endpoints are configured, you still need monitoring. Start with the telemetry supported by the PaaS service. Enable the appropriate diagnostic settings and send relevant logs and metrics to your monitoring platform, such as log analytics. Then monitor the configuration itself. Did someone enable public network access? Was a firewall rule changed? Was a new private endpoint created or removed? Did a resource drift away from your Azure policy requirements? Defender for Cloud can also help surface security recommendations and exposure risks across supported resources. The exact logs and alerts available vary by service, so don't assume every storage or SQL network event automatically generates the same telemetry. The enterprise pattern is configure, monitor, detect drift, respond. Don't reduce service endpoints and private link to arbitrary security scores. Private link isn't automatically secure just because it uses private IP addressing. And service endpoints aren't automatically weak just because the service retains a public endpoint. Security depends on the complete architecture. Service endpoints provide a simpler way to restrict supported PaaS resources to trusted Azure virtual networks and subnets. Private Link provides a private IP-based connectivity model that can support stricter isolation and hybrid connectivity requirements. But Private Link also introduces more DNS, IP addressing, routing, governance, and operational considerations. So instead of asking, which one gets the higher security score? Ask, which architecture satisfies our security requirements with the least unnecessary complexity? That's the question an architect should answer. You may hear this described as a maturity path. Start with service endpoints, then eventually graduate to private link. But that's not always the right way to think about it. These technologies solve different connectivity requirements. A low-risk internal application may use service endpoints for its entire lifecycle. A new regulated workload may require private link from day one. Another application may need private link immediately because on-premises systems require private connectivity. So don't deploy service endpoints because you're a beginner, and private link because you're advanced. Start with requirements. Where are the clients? Can the public endpoint remain available? Do you need hybrid connectivity? What are the compliance requirements? What does the service support? Then select the architecture that fits. Final architecture checkpoint. Your company runs Azure SQL database. Azure applications need access today, but an on-premises application will also need private connectivity through ExpressRoute next month. Security requires clients to connect through private IP addressing, and public network access should be disabled. Which architecture should you evaluate? Private link with a private endpoint. The private endpoint provides the private IP destination. Your VPN or ExpressRoute connectivity provides the network path from on-premises. Your DNS architecture ensures clients resolve the SQL service name to the private endpoint. And the SQL network configuration restricts or disables the public network path according to your requirements. Then identity and database permissions determine what authenticated users and applications can actually do. That's the complete architecture: private connectivity, DNS, public network restrictions, and authorization. Let's lock in the three biggest lessons. Number 1. Understand the data path. Service endpoints allow supported PaaS services to recognize authorized Azure VNets and subnets while clients continue using the service's public endpoint architecture over the Azure backbone. Private endpoints give your clients a private IP destination inside your network for supported Azure services. Number 2. Private endpoint does not automatically mean private only. For a strong private access design, think about private endpoint, DNS, public network restrictions, and identity and authorization. Number 3. Network access is not data access. A client being able to reach a storage account doesn't automatically mean it can read the blobs. A client reaching Azure SQL doesn't automatically mean it can query the database. Networking controls reachability, authentication, and authorization control access. If you understand those three concepts, you understand the foundation of securing Azure PaaS connectivity. DNS was one of the most important dependencies in today's private link architecture. In the next part of the series, we'll go deeper into Azure DNS, public zones, private zones, and hybrid DNS architectures. You'll learn the core private DNS zone, VNet link, and DNS validation workflow. We'll also look at why hybrid environments may require DNS forwarding or Azure DNS Private Resolver, so on-premises clients can correctly resolve Azure private endpoints. That's next. Here's your homework. 3 concrete moves. First, take a development storage account and configure the complete service endpoint pattern. Enable the service endpoint on the application subnet. Then restrict the storage account's network access to the authorized VNet and subnet. Second, choose a SQL database that requires private connectivity and sketch a private link architecture. Include the private endpoint, DNS, public network access configuration, and identity controls. Third, build and validate one of those designs. Don't stop when the portal says, "Deployment succeeded." Test connectivity. Test DNS. Test authorization, and verify that unauthorized network paths are denied. That's how you turn an Azure feature into an architecture skill. If this series is moving your career forward, hit like and subscribe so you catch part 11 on DNS the moment it drops. Every video is one real-world skill you can deploy by Monday morning. No fluff, just forward momentum. Keep building. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.